Plants based on pyrolytic technology transform organic-type discarded materials in non-contaminating gases for industrial applications. The requirements of the power supply of the plant are fulfilled by the produced gases. The excess gases are used to provide electrical energy. The quality of the emissions depends on the fuel quality. Indeed, the combustion of non-contaminating gases leads to non-contaminating emissions. An ordinary treatment plant based on thermal processes produces a level of emissions which is 5 times higher than that provided by a pyrolytic-based installation, with the same conditions of material discarded. The dimensions of the plant are extremely small. In fact, it can be installed on an area of about 2,000 square meters. Thus, from an environmental point of view, the plant has a low visual impact. The pyrolytic-based plant can properly treat pre-selected RDF, fragmented waste, and any other kind of solid and liquid discarded materials, which can be both dangerous or otherwise, and can be of either industrial or medical origin. In case of necessity, the installation is able also to treat mixed solid urban waste. This is transported by road and deposited in specially pressurized trenches which eliminate smells. The requirements of the power supply of the plant depend on the type of the material being treated. In the case of solid urban waste, a grabber is used to pick up the waste from the trenches and to fill the hopper. For RDF type materials, the hopper is filled by a conveyor belt. For any other kind of waste, a forklift truck is used to lift pallets to fill the skip. The skip, which is hydraulic, feeds the hopper. At this point you can see the hydraulic loading system. The hopper forms the tank necessary to feed the hollow lying below, where a knife press is located. This press is used to compress the discarded material and to grind it into powder. Once the waste has been ground into powder, it is collected in a hopper lying below, which via a conveyor feeds the pyrolytic reactor. The pyrolytic reactor consists of 2 elements. The first element is a horizontally rotating cylindrical chamber of inox steel and inserted in a coaxial oven, which is lined with a refractive material. The second element is a cylindrical chamber around a vertical axis. This chamber is also lined with refractive material, and a burner is located on top of it. The burner burns clean pyrogas and carbon waste charcoal. which are produced by the pyrolytic process. Inside the rotating drum is a helix, which is used to take away discarded material. The combustion chamber produces smoke, which before being expelled passes through the cavity between the tubes of the rotating cylinders, thus allowing its heat to be reabsorbed for further use. The waste inside, moving in the opposite direction from the smoke, absorbs this heat, thus continuing the process. The pyrolytic gas extracted from the reactor passes through a vacuum chimney to remove the ash. The stainless steel tubes taking the gas out of the unit pass through a limestone spray tower, Venturi type, for cleansing. The gases are then lime washed to neutralize the acids therein. A fan takes them to a pressure stabilizing tank where some of them will be channeled back to the unit's burner. Residual waste, consisting of natural inorganic material, after treatment is extracted by conveyor, cooled and packed into special containers. At the end of the conveyor belt, a fan extracts the charcoal dust for reuse in the combustion chamber. The combustion smoke reused to maintain the reactor's processing temperature is passed through several treatment processes: a vacuum process to remove ash, a heat exchanger to cool the smoke, and a fabric filter with exhaust fan to the chimney. This treatment guarantees the quality of the emissions. The greater part of clean pyrolytic gas produced goes to generate electricity. To ensure complete security, any unused gases are burnt off by an external flame. The process described shows the benefits of the waste treatment system with significant production of clean energy. Waste, not a problem, a resource.